Hello everyone, myself Ashish Desai, Assistant Professor, Surgeon of Technology, College of Engineering. Today we are going to discuss the robot programming. On Wall 1, that is Variable Assembly Language. So in that Wall 1 programming, we are going to discuss the program on welding operation. So before that, we are discussing the Wall 1 program on welding operation. So we are going to discuss the first robot language elements and functions. So already we discussed in the session number 1, which is Wall 1 programming. So in that case, we are discussed already that is about constant variables and other data objects. So which is present for the robot language and motion commands. So that is about motion about related with robot movement, that is move straight line, that commands we already discussed. Then end fit and sensor commands, so here we are getting the signals from the sensors and that outer periphery, and then we have to complete their actions for the open up and close up the gripper and then actions. So that is useful for the end effector and sensor commands. Then nextly we are operating the computation and operations here, addition, subtraction. So that relative operators we are using for the conditionizing the algorithm, logarithmic operators we can use over there. So this such type of computation and operations already we discussed here. Then program control and subroutine. So main program is having in the same format. So we are this data will be in this program, or these lines are coming in a same way. That's why we are routing in a subroutine format, and then main program and subroutine program we are developing in a such a way that that is the case we are developing in the program control and subroutines the commands. Then communication and data processing. So here we are fetching the data from the data from the teach patent, and we are getting the information in the edition mode of the editing mode for the change in the program. So that can be processing also we are possible through this teach patent and that program codes. So this is the possibility we are creating in the program language and elements. So while discussing the this program languages, so first of all we simple write a program for the latest robots, by latest robot in wall language. So the two letters we are doing with the that robot wall language, that is K and S. So first of all we discuss the K part. So simply we are writing in a format of move safe. So move safe, that is landing will be there, then signal 6. So here the the sensor will be on, the signal will be getting from the one side, and then move intermediate. So immediately move at the intermediate point, then move loc 1, so that is location number 1. So this is point number 1 we are getting here, so that is move location 1. Then next move location 2, so they're moving from 1 to 2, then move location 2, then move location 3, then again we come into the location number 3, then it is go to the 4, and again that move location 3, so again it can reach to the move location 3, and then move location 5. So this is the straight line manner it can be perform their work. So that is about the location 1, location 2, location 3, location 4. We are location 5 that may be decided, or that may be written in the defined constants. So we can get in the exact that k letters which is in a welding operations. Similarly we are giving the same way format, that is for the S letter. So first of all we move enter 1, then move safe, then signal 5 is getting the sensor signal, and then move safe, then wait for 12, that is about wait at a some minutes, so that is 12 minutes wait. After that signal 6, so we are getting the another signal from the system, and then move enter 2. So intermediate point number 2 it can be stated over there, and then move location number 6. So this 6 location will be getting, and after that move location 7, move location 8, move location 9, then move location 10, move location 11. So like that format we are written in this basis. So it is local level language we are writing like this only. We are writing in the wall 1 programming. So it is useful for animate robots, which is developed by this robot company. And then we are using the local language we are using for that, that is more enter 2. Again it is go to the back position, that is move enter 2, and move safe, then signal 5, that is getting from the signal by the sensor, and then end of the program. So this is about the program we are discussing the S format. So these two letters already we discussed in the wall programming. So this is simple program we are rated here for the operation of welding. So this is the format we are discussed over here. Similarly, we are going to discuss the next complicated program. So for the welding operation, so some program will be assisted with WSET. So WSET command indicating that the speed welding voltage and current as a welding condition identified by the number 1 to 4. So this is about the mentioning the that condition, as well as we are mentioning here speed and voltage and as well as current. So these are the 3 points: speed, voltage and current we are mentioning at the W set. The that is one first set. Then W set, W start, the start welding condition and weaving condition. So we can get the data for the W start. The next W end. So W end zero point 0.5. That means what? After the signal, we can get the start. So that means what? 0.5 minute we'll get pause, or can say welding stop operation, and then perform the action. That is about W end. In character fill, the instruction is used where the character filling is required. So whenever two different components are there, so that time melting point is also different. So this condition or this case, we are using the character fill command, and then we can fill up the this filler content, and then welding will be done. So this is the weldment will be do this action of character fill. So these are the three commands. This is useful for the different welding programs, and this is the important one. So firstly we discussed the W set one, W set, then W start, then nextly that is about where W end, and then we have discussed scatter fill. So these are the four commands which is useful for the different operation of welding. So we'll discuss this program in a wall one. So here there will be program which is we are traveling the that welding torch from this x1, that is point x1 to x11. So these points we are traveling over there, and we are doing the welding part. So this x1 is called as home position, x2 and x3 is for triangular weaving. So this is nature of weaving style will be weaving. Then circular part, that is about x4, x5 and x6, that is about circular arc, or you can say circular interpolation. Then next x5, x6, x6, x7, x8, that is about circular arc. Then x10 to x11, that is about trapezoidal path, and here x9 to x10 it is called as straight weld. So this is the condition we are defining for the that case. So this is important type we consider over here. So maybe discussion on that. So first of all, W set 1, because every time we are changing the that profile, that is traveling view, sometimes we are changing in a circular pattern, sometimes we'll change in a trapezoidal part. So these three weaving conditions we are operating that level, that is W set 1, W set 2, W set 3. So first of all we discuss about the W set 1. What is mean by W set 1? So actually that condition we are defining in W set 1. So firstly we are discussed in the previous slide, that is about speed, welding voltage and current. So these three parameters we required to mention here in a welding set 1. So here it is not mentioned because it is generalized statement or generalized program is there. That is why only we write here W set 1. So this is for setting for the triangle view. And then W set 2, that is for weld. So in that case we are discussing for W set 2, it is for that sometimes we required in a straight line path, or sometimes required in a curvature part. So that time we require W set 2 condition, and here also we mention that is voltage, current and that speed also we are mentioning over here, that is W set 2. Similarly for W set 3, here also we are mentioning this, that is about speed, then voltage and current, and we are discussed for the trapezoidal view. So here approximately W set 1 2 3 4 is present. So W set 1 2 3 we are using for the three conditions, is it? So now we are discussing the WV set, that is about the viewing set for the one, and this WV set 1 is useful for the condition which is change in a path, that is about triangular path we are developing for WV set 1. WV set 2 is whenever the trapezoidal bearing is there, so we can use the WV set 2. So this is the command we are utilized for the WV set 1, WV set 2. So here weaving pattern is available, that is why we require a different set also. and that is why we are placing the wv set 1 and wv set 2. So now we are going to discuss the program of the this this nature or this profile. So first of all, we go for the move x1, so that is your home condition. Then move x2, then w start 1 1, that is about set 1. So whenever one point is there, so at time w set 1 is there, so we are using for the straight line path. Or so for moving for the x2 to x3, in that region we are region utilizing the triangular path. So that's why w start 1 1 is utilized over here. So w start 1 means what, we are first initiation the condition, and 1 means what, w set 1. So this 1 1 means what, w start 1, that is your first start condition, and this one is for w set 1. So these two conditions stated for the w start, and then moves x3, then it goes to the moves x3. Then we can take a pause, that's why we can write w end 0.5. So this is 0.5 seconds, we can rest over there, and after that we can change your next path. That is why we're writing in the format of w start 2. So second start position is there, again we use the set 2 condition, that is w set 2, because we are changing the profile, that is our straight path and circular path. That is why using the w set w start 1 1. Okay, and here we are using the w set 2 value, and that is why we are using the condition, that is about w start 2 2. Is it? The next is about moves export. So after that it is goes in a moves, that's why s is written here. That is why the x3 to export, it is the weld will be state 1. So that is why we written as a w moves export. Then again, the present of x4 x56, there is about circular path, so it is already mentioned, that is circular interpolation. That is why x4 x5 x6, so this is the path for the circular arc, so only we write the circle. The next about goes to the straight line in a x7, that is x6 to x7 moves x7, and then again we are having circular arc, that is from x7 x8 9. So that is again we can write circle x7 x8 9. Then moves extend, so here it is a straight line path, and there is no profile change is required, because already we set it for the w start 2 value, and that is the reaching at the w, that is moves extend, that is about straight line path. Then next leave we are w end for 0.5 seconds, that is for resting of the path, because already we changed the path from triangle view to circular view, and that is why we change the w end 0.5. Again that next point, that is about w start 3 1, that is our third station. We are initializing the condition, and we are using the viewing pattern, that is set 2, because we are using the trapezoidal path over here. So that is why w set 3, that is 3 conditions, and 1 will be, that is our view condition. So we can write here w start 3 1, and then moves x1, that is x11, that is in straight, that is in path. So that's why we reckon as a create fill 0.83. So this is about filling materials, and that can be helpful for the filling of your the materials which is in required in a weldment. So that is why we are returning as a creator fill 0.83. So that is again we are mentioning the values over here. Then again rest for 0.5 seconds for the conditionation will be tested over, and then after that move to the x11, oh sorry, x12, and then end of the condition. So this is the program which is generalized for the welding purpose or welding instruction sets we can follow for the wall programming, which is useful in animate robots. So these are the parts we are discussed in this content or in this lecture. So in the wall 1 programming, so welding operations, which is mostly important for the exam perspective, so that we can do the wall language in a later format, as well as we are getting in the instruction set for the different curvature parts also we can take in the interactions. So these are the parts we are discussed in this content. So thank you.